Hi Rangers, today we're going to talk about dilations of quadratic functions. So dilations are another way to transform quadratic functions. In a dilation, the parent function is going to be multiplied by a given value that can be represented as y equals a times f of x, where a cannot be 0. It can't be 0 because if it's 0, then it would not be a quadratic function. So what we're going to do is, on question number 1, the graph of f of x equals x squared is shown to the right. Remember that this right here is the parent function. Okay, and we're going to use a graphing calculator to help us with A through C. So first thing we're going to do is we're going to graph g of x equals 1/2 x squared, and then we're going to sketch it and label it on the graph. So we're going to go to our calculator, we're going to type this in right here and graph it. So I go to a new graph, I'm going to type in 1/2 x squared, press enter, Control T to get my table. Okay, now I see a lot of decimals, that's perfectly fine, but we're only going to worry about graphing the whole numbers. Okay, so we're only going to worry about graphing the whole numbers. So I'm going to go from -4. So -4/8 is right here. I have -2, +2, which is right here. And then I have 0, 0, 2, +2, and 4, 8, which is right here. So I'm going to connect those points. And I have my quadratic function g of x. So let's label it g of x, that way we know. Okay, then it wants us to graph 2x squared. Okay, so we're going to graph that. Let me go back to the notes so I can switch colors real quick. Okay, so I'm going to switch to blue. And then we're going to go to our calculator and graph it. So we're going to go to a new document. And we're going to graph 2x squared. Enter. Control T to get the table. Again, I'm only going to graph what I can fit on my graph. So I'm going to start with -2. So I have -2, 8, which is right here. I have 1, 2, which is right here. 0, 0, 1, 2, 2, 8, right there. So I have this quadratic function right here. And then we're going to label it h of x. So blue is h of x. So let's go back to our notes and see what it has asked us. So for each function on the list the a value and describe the effect it had on the graph of the parent function. So g of x had the a value of 1/2. And what happened from a, what did that a do? It caused our parabola to be wider than f of x. Notice how it's fatter. So this made the parabola wider than f of x. Okay, h of x had an a value of 2, which made the parabola skinnier, right? So we're going to use narrower. Okay, so notice how it's a little skinnier. So, summarizing what this means, if the absolute value of a, meaning we're not worrying about a negative sign, is greater than 1, then it's going to be a vertical stretch. That's the one that made it look skinny. And then that makes the parabola narrower. So on the STAR test, they could use either word, stretch or narrower. So you need to know when it's bigger than 1. It is narrower or a vertical stretch. And again, vertically. Okay, when A is between 0 and 1, it's going to be vertical compression. Which makes our parabola wider. So again, the STAR test could use either one. So vertical compression or wider. So think of narrower as skinny, wider as a little thicker. Okay, so the graph of f of x was transformed to create r of x. Use the graph to answer questions 2 and 3. So we have f of x, and then r of x is our dotted one. If r of x equals n times f of x, which of the value is a possible value for n? Well, it did get wider, so to be wider, it needs to be between 0 and 1. Okay, so it cannot be bigger than 1. So that means we can eliminate answer choice A for sure, and the absolute value of -4 is +4, so that's bigger than 1. If we think about 4 over 3, that is 1.3 repeating, so that is also bigger than 1. So then that leaves us with C, which is between 0 and 1. Okay, perfect. Now, identify the key features of R of x. So let's go ahead and do that. So the vertex of R of x is 0, 0. The domain, axis of symmetry is x equals the x value. The domain has 2 arrows, which means it's all real numbers. And then the range, the y values are getting greater than or equal to that minimum value of 0, which is the y value of the vertex. So circle the key features of Rx that are the same as f of x. Well, all of the key features are the same, right? Because my vertex of my parent function is 0, 0, which means its axis of symmetry and range are correct. And the domain is all real numbers unless it's a real world situation. So all of them are the same. Number 4, Alicia will transform the parent function of f of x to create 5x squared. Should the parabola of p of x be narrower or wider than f of x and y? Well, our a value is 5, which means it's bigger than 1, which means it's going to be narrower. So it's going to be p of x will be narrower. Because a is greater than 1, so it is stretched vertically. Okay, now if Alicia changed her value of a to be -5, so that p of x equals -5x squared, what additional effect would have on this graph? Well, if we graph that real quick so we can see, I'm going to go to a new graph. I'm going to type in -5x squared so we can see what happens. We already know that that 5 is going to make it narrower, but it also causes it to reflect down about the x-axis. So a negative a value causes a reflection about the x-axis. Okay, moving on to the back side of our paper, we can also use y equals f of b times x, so the b is on the inside, to multiply the input by values to dilate quadratic functions. So complete questions 6 and 7 to see the different values of b will affect the graph f of x shown. So sketch and label the graph of Rx. That is 1/2 x squared, and s of x, which is 2x squared. So notice how the numbers are now inside the parentheses. So we'll start with r of x. Let me go ahead and change to red. Get my calculator set up, and it was parentheses 1/2 x squared. Up, the squared is on the outside. So like that. So make sure your squared is on the outside. We're going to go Control T to get our table, and then I'm going to put our notes up on top. Okay, so here we go. We're going to graph what we can. Looks like I can graph starting at -6. So I have -6, 9, which is, oops, right here. I have -4, +4, which is right here. I have -2, 1, 0, 0, 2, 1, 4, 4, and 6, 9. So I'm going to connect my dots. There we go. A little bit. Okay. So this right here we're going to label as R of x. So red is R of x. And now we need to graph. What do we need to graph? S of x, which is 2x squared in parentheses. So I'm going to get rid of my notes. We're going to get a new document. We're going to parentheses 2x, close parentheses, squared, enter. Okay, I'm going to go ahead and change my color on my pen. Okay, and then we're going to go Control T to get our table and put our notes back on top. Again, we're only going to graph what fits on our screen. So it looks like just starting at -1. So I have -1, +4, 0, 0, and 1, 4. And this is S of x. So let's compare them. Each function lists the value of b and describe the effects it had. So the b value for R of x was 1/2, and it caused our graph to be wider than f of x. Caused the parabola, let's use math terms, to be wider than f of x. And then we go to S of x, which is our b value of 2, which caused the parabola to be narrower. Okay, so let's go ahead and the effects of f of b of x depend on the value of b, and let's summarize what we learned so far. So when the absolute value of b is greater than 1, then it is going to horizontally compress. The parabola, making it narrower. So the important part here is that we know it's horizontally when it's on the inside and that it's compressing, which means it's narrower. Okay, so we're compressing it horizontally, which means it's getting narrower. So we're squeezing it left and right. Okay, then we have when the absolute value of b is between 0 and 1, it's going to horizontally stretch the parabola, making it wider. So we're pulling it from the left side and the right side. Okay, so that's what the stretch versus compression means when it's horizontal. So it's important to know between 0 and 1 and bigger than 1. So Carla makes a graph of the function g of x equals 1/4 x squared, and Marcus makes the graph of 1/4 x and then squared on the outside. Which student's graph will be wider than the parent function? Well, let's graph and see. So let's start with our parent function in y1. That way we know this is our parent function. So I hit tab. I'm going to type in Carla's graph first, which is 1/4 x squared. So hers is wider. So I'm going to hit tab, and now I'm going to type in Marcus's graph. So parentheses 1/4 x and the squared on the outside. His is also wider. So they're actually both wider than the parent function, so it's going to be C. Okay, now the graph shows f of x equals x squared. Joe sketches g of x, which is -4 f of x minus 1. Did he graph it correctly? Well, we know that negative causes it to reflect, that -1 causes it to go down, but the 4, remember the absolute value of 4, or of -4, I'm sorry. The absolute value of -4, which equals 4, is greater than 1, which means it should be narrower from our first page. Okay, it should be narrower, and it kind of looks like it's wider. So, no, he did not graph it correctly. The graph should have been narrower than f of x. Okay, and this one, g of x is wider, so that's not the correct graph. Okay, Octavio will transform f of x to create the following functions described. Which function represents the following? So we want to create a of x, which is a vertical stretch by a factor of 7. So vertical is when it's on the outside. So we have two options. We have a of x just equals 7x squared, or we have a of x, which equals 7 times f of x. Those are the same thing. Okay, now the function b of x is going to be a horizontal stretch by a factor of 4/5. So a horizontal stretch, all that means it's going to go inside the parentheses. So we have b of x equals 4/5 x and a squared on the outside, or b of x equals f times 4/5 x. So either one is correct. So which of the functions will have a graph that is narrower? Well, the one that's going to be skinnier is going to be our vertical stretch. So answer choice A. So A will be narrower than f of x. Okay, last but not least, A through D gives descriptions of transformations of x squared. Match the description to its function. So let's see. I like to start with what I know. So let's look at P of x. I know that this right here is going to cause a reflection, and then that 6 is going to be a vertical stretch. So I want a reflection and a vertical stretch, which is answer choice B. Okay. Now, m of x, the 9 on the inside, that means it is going to be horizontal. And when it's bigger than 1, it's a compression. So I want a horizontal compression, which is answer choice D. R of x, it's on the outside, so it's vertical. And it's between 0 and 1, which means it's a vertical compression. So I want vertical compression as a description, which is C. And then H, I have that negative, which causes a reflection. It's on the inside, so it's horizontal. And it's between 0 and 1, so it's a stretch. So that would be A. So please make sure you remember to summarize and write down any questions you may have. And don't forget to ask your teacher.